Okay, today we're going to talk about the Learning Standard 8G5 and the Common Core State Standards. And in particular, there's nothing in particular about the standard that we're going to talk about. This is actually going to be used for the next lesson where we have to talk about angles that are created when parallel lines are cut by a transversal. So this vertical angle lesson will help us with the lesson that I outlined above, which will be the next lesson in this series. So vocabulary is vertical angles, linear pairs, supplementary angles, and complementary angles. So first let's review. Complementary angles are two angles that add up to 90 degrees. So right now you can see in this angle right here, this larger angle which is 90 degrees. I'd actually have to tell you that beforehand. So in this picture right now, X and Y are not complementary angles because I haven't identified this larger angle as a 90-degree angle. If I wanted to, I'd have to write that. Or I could even be a little bit more clever about, sometimes you'll see a situation where they'll make angles like this, and then they'll make one of the other angles a 90-degree angle by using that geometric notation to indicate that this angle is 90 degrees. Okay, that means that these two lines are perpendicular to each other. That means that these are all 90-degree angles, including the one that is split up by this ray. Okay, so in this case, x plus y equals 90 degrees. So x and y are complementary angles. Complementary angles can only be a pair of angles. It can't be three angles or more. Supplementary angles add up to 180 degrees. So what that sometimes looks like, if they're supplementary angles and they're linear pairs, it looks like you have a straight angle right here, and it's been split up by a ray. Okay, and you have x and y right here. And what you know, by the way, when you have supplementary angles that are linear pairs, or any pair of supplementary angles, unless there's two situations that could happen. Situation number one, they're both equal to 90 degrees. Okay, situation number two, one is obtuse, which we're going to go over in just a second, and one is acute. Okay, so if we look at these angles right here, y would be obtuse because it's greater than 90 degrees, and x would be acute because it's less than 90 degrees. And that sort of makes sense, right? If we know that x plus y equals 180 degrees, then unless they're both 90 degrees, then one will say, like, if x is 20 degrees, then y has to be whatever you add to 20 to get to 180, which is 160. Right? 20 is acute because it's less than 90, and 160 is obtuse because it's greater than 90. So the other review that we had to do was acute, which we just talked about, means an angle that's less than 90 degrees. By the way, a 90-degree angle is also referred to as a right angle. Obtuse means more than 90 degrees. And people often remember that because the prefix OB can mean things like obese means overweight. So obtuse means larger than 90 degrees. And a straight angle is equal to 180 degrees. And that just looks like a straight line. Okay. Now some common mistakes here. So oftentimes, I see this all the time, and this is the first thing that you'll learn in geometry class, is that when you see this figure on the left here, you'll see two lines that appear to be perpendicular. And so what a lot of students will say is, oh, okay, this is a right angle. They'll sort of, but notice that in the drawing I did not give you that information. I did not draw that little square inside the vertex of that angle. Okay, unless you are specifically told that an angle is a right angle, you cannot assume that that's a right angle. Okay, so in our case right here, we were not told, so we cannot assume that this is a right angle. Likewise, if we're given a triangle that looks like a right triangle, like this triangle for all of our eyes will look like a right triangle, but remember, our eyes can't tell the difference between an 89-degree angle and a 90-degree angle, right? It probably can't even tell the difference between an 87-degree angle and a 90-degree angle. So you can't, unless you are given this little indication here, you cannot assume that a triangle that looks like that is a right angle. That is a huge mistake that students often make. Okay. And one more piece of information here. Adjacent angles are two angles that are next to each other. Adjacent angles are not always linear pairs. Okay? In fact, these 1 and 2 are not linear pairs because they do not make up a straight line. Right? The two rays at the end here do not form a straight angle. So angle 1 plus angle 2, or the measurement of angle 1 plus the measurement of angle 2, do not equal 180 degrees. Okay? And vertical angles are angles that occur when you take two lines and intersect them. So you take these two lines, you intersect them, and vertical angles are the angles across from each other, the ones that are not adjacent. Okay, so the vertical angles I'm going to put, okay, 1 and 2 are a pair of vertical angles, and let's see, 3 and 4 are also a pair of vertical angles. Now, 1 and 3, there's also a bunch of pairs of adjacent angles. So let's see, adjacent angles would be 1 and 3, okay? Another pair, actually let me just write them down. So you should have this diagram in your notes too, because it's important to understand the pairs of adjacent angles would be angle 1 and angle 3, angle 3 and angle 2, angle 2 and angle 4, and angle 1 and angle 4. The vertical angles, however, are, there's only two pairs of vertical angles. Angle 1 and angle 2 are a pair of vertical angles, and angle 3 and angle 4 are vertical angles. Okay, vertical angles are opposite each other when two lines intersect. Okay, and those are the angles that we're going to be talking about today. So in order to understand vertical angles, let's go back to our diagram of a triangle. Now, we learned the other day that if you extend the line of a triangle like this, that this exterior angle, let's call this exterior angle D right here. So we have four angles in this diagram. We have angle A, B, C, and D. We learned that the measurement of angle D was equal to the sum of the remote interior angles. And likewise, if we extended this line right here and we called this angle E, the measurement of angle E is equal to its remote interior angles. Right? When I say remote, I'm saying remote relative to E. Right? A and B are remote relative to E, but B is not remote relative to D. It's right next to D. It's adjacent. Okay. So, but the strange thing about this is, so let me keep this up, and let's keep this up for a minute. I want to show you something strange that happens here. Okay, there's two ways to extend this line. I extended this ray right here to create the exterior angle, right? But I could have also extended this line right here. Then if we look at the relationship between C and this angle is also, let's label with a color for a second so I can speak about it. The red angle and C are also, they form a linear pair, right? So we know that the red angle is equal to because it's an exterior angle, it's also equal to the sum of the remote interior angles as well. So that's equal to angle A plus angle B, right? So what's strange about it is that, let me label this other one, E is blue, right? What's so strange about this is that angle blue is a supplement to C, and the red angle is also supplement to C. So we know the blue one plus C is equal to 180 degrees, right? And we also know that the red one plus C is equal to 180 degrees, right? Well, if you look at this structure, since the blue plus C is equal to 180 degrees and the red plus C is equal to 180 degrees, 180 degrees is the same number, so that I can say that the red plus C equals the blue plus C. But if you subtract C from both sides, what you're going to end up with is this identity, that the blue is equal to the red, right? So what we know here is that these two angles, the red here and the blue there, are equal to each other. Okay, so look at how these lines are intersecting. Let's go back to our definition of vertical angles. This is exactly what we see. Like, this is the top of the triangle we see there. So what we know right now is if we even take the triangle out of the situation, that when two lines intersect, the vertical angles are equal to each other. So this angle is equal to this angle, and we also know that this angle is equal to this angle. Okay, and we can just see, we actually can see that without using a triangle, because if if the pink and the blue make up a line, right? The pink and the blue make up a line. Then if I'm trying to find what this angle is right here, well, we know that this angle right here and the pink make up a line, so that these two angles must be equal to each other. Okay? So in vertical, so whenever you have angles like this, let's count. Let's call these 1, 2, 3, and 4. All vertical angles are equal. Oops. Angles are equal. Okay, so 3 and 4, the measure of 3 and 4 are congruent, or angles 3 and angle 4. There's two ways of doing it. Angle 3 is congruent to angle 4 is congruent to angle 3. That means that the measurement of angle 4 is equal to the measurement of angle 3. And likewise with 1 and 2. Angle 1 is congruent to angle 2. That means their measurements are equal to each other. Okay, so let's use that to solve some of these problems here. If I'm looking to solve for A, let's just be aware of what's going on. I have this little triangle, so I am given that this is a 90-degree angle, which means that A and 67 are complementary. So I can set up an equation here. A plus 67 is equal to 90. So I can subtract from 67 here. Oops. So A is equal to 23 degrees. Okay, I guess vertical angles didn't necessarily help us in this case right here, but this was an example of how to find an angle when you have its complement. Okay, in this next situation, vertical angles will help us. Now it's a little bit complicated because there's 3 lines here. So what you want to do is you want to sort of track the 2 lines that fully intersect. So these blue lines, you want to focus on these blue lines for a minute here. Okay, these are the ones that intersect. This orange, I'm going to mark this in orange. This line right here doesn't go fully through those 2 lines. Okay, so we're not going to pay attention to it for a minute. Let me just erase that. So what we know is that since the blue lines intersect each other, that Y and 56 degrees are vertical angles. That this angle right here and this angle right here are equal to each other. Okay, so Y must be equal to 56 degrees because it's a vertical angle. Okay, now something else that may help you in this situation, so I need to find X and Z as well. So let's look at Z for a second. We know that Z and 56 are supplementary angles because this line right here is a straight line. So we know we can set up the equation Z plus 56 is equal to 180, and then subtract 56 from both sides. So 124 is the measurement there. Okay, so that's 124. And so what we can also see is that if I look at this other side right here, that is the other component to the, let's see, let me erase these lines for just a minute so I can show you again. Alright, so what we know so far is that that's 56 degrees, and if I look again at these vertical angles, this one right here is 124. So I know that this large thing is 124. Okay, oops, 124 degrees. I also know that since that is 90, I should be able to get my, I can get my X from 2 different ways. I can think of it as, okay, it's 124 minus 90 is equal to my angle X. Okay, I also can tell that X and Y are complementary, so I know that X plus 56 is equal to because I know that y is 56, that's equal to 90 degrees. So there's two different ways I could get what my x is. So let me just get at this bottom way here. So x must be equal to 34 degrees. Okay, so I have solved for all of my my variables here. I know that x is equal to 34 degrees, that y is equal to 56 degrees, and that z is equal to 124 degrees. Okay. Now I'd have to solve, let's see if I can solve for my x and y in this situation. So you might be able to do this already, so you might want to pause the video and come back to it when I'm finished. So we know that the vertical angles are equal, so I can set up this situation. 53 is equal to 3x plus 5. I can proceed to solve this. 3x must be equal to 48. Divide by 3. X is equal to 16. Okay, so if x is equal to 16, actually I didn't even really need to do that because I actually worked more than I should have. If this is 53, if this one's 53, then we know this one's 53. And since we know, oh, I guess I needed to solve for x and y, so I did have to solve for x. But if this whole thing is 53, that means that y plus 53 degrees must be equal to 180. Y must be equal to 27 degrees. Oh, 127 degrees. Okay, so these are my two answers for this one. Now in the next one, I complicated a little bit more by putting the streets in, 42nd Street, 41st Street, and Broadway. If you've ever been to Broadway in Manhattan, it actually runs at a diagonal along Manhattan, which is really strange because the avenues and the streets all run parallel and perpendicular to each other. So Broadway's it's an old Indian or an old Native American trail, so it runs when you're looking at Manhattan, Broadway runs like up like this. Okay, so it creates a transversal because 41st Street and 41st Street and 42nd Street are parallel to each other, and Broadway runs so that it's a transversal between them, which is actually, thinking about this lesson, we haven't defined transversal yet, but we can just see this situation right here. If we have Broadway here and 42nd Street there, and this is 3x plus 5, and this is 47, and we have 10x minus 7. There's a couple different ways that we can solve for x. First of all, we know that these two things are a linear pair, so we know this property. Okay, and we also know that these are vertical angles, so we know this property. Okay, I'm going to solve this other one right here. So 3x is equal to 42. So divide by 3, divide by 3. Let's see, so x must be equal to 14. Okay, and that would be in degrees. Okay, I can always check myself by putting x into this second one. Should be equal to 180 degrees, right? So this was 42 plus 5, this was 47 plus 140 minus 7 is 133, and that does get me 180 degrees. Okay, so what you learned today was, you learned about vertical angles, which are the pair of angles that are created when two lines intersect. Okay, and you learned that those pair of angles are equal to each other. Okay, and then you use that to solve equations, to solve situations that force you to set up equations like the ones that we just did.